Hello, my name is Zach Hughes, and our project focuses on the mapping of an underwater topography of a lake using a submersible pressure transducer and a GPS system. The goal of this experiment is to measure water depth at many different locations and use that data to then generate a topographic map of the lake floor. We accomplish this by measuring hydrostatic pressure within a submerged pressure transducer, and since pressure increases with depth, we can then use the hydrostatic pressure equation to calculate the depth of the water at each point. A GPS system is used simultaneously to record and extract coordinates where each measurement is taken. By combining the depth data with the GPS location data, we then can construct a spatial map showing the shape of the features of the lake bed. Ultimately, this experiment demonstrates how instrumentation and measurement techniques can be used to collect environmental data and convert that data into meaningful information about real-world systems, and in this case, the topography of the bottom of a lake.
This experiment covers the following topics discussed in this course. For both density and pressure, we use uncertainty propagation theory to find the total overall uncertainty of the measured variables. Then for our pressure, we can use our pressure data points from the pressure transducer to form a linear regression line. And from that, we can then determine our sum of squared errors. And using that value, we can then find our standard deviation. And with that standard deviation, we can then use our z-table to find our total uncertainty based off of a 95% confidence interval. And using that, we are able to find our pressure with its total uncertainty range. The first gap within this experiment is the potential currents within the water due to chlorine circulation and other swimmers, which can cause the boat to move and affect data collection. To address this, data will be taken when there are no swimmers in the pool and in the middle of stagnant water, where effects from circulation are negligible. The second gap relates to the potential movement of the pressure transducer while it is collecting data. This will be mitigated by attaching weight to the transducer.
The variables in this experiment that we are going to measure is the weight and the voltage. The weight will be about 500 grams. The voltage will be between 0 and 10 volts. Our errors we are expected to occur during this experiment are due to our instruments, which we will account for by using higher precision instruments, and our bias errors will be accounted for during our calibration of the curve of the pressure as we lower the transducer into the water. Our uncertainties are expected to be between 0 and 6.73 centimeters for height and 0 and 11.89 kilograms per meter cubed for the density.
Hello, I'm here at our test facility. We are at the Hyper secondary pool. As you can see here, this is where we're planning on doing our tests. We are able to put canoes and kayaks in there. That's what we use to get depth measurements in the middle of the pool. We will, if you look, it ranges from 3 to 7 feet in depth. So we do have that set depth there. We do also have outlets on the wall that we'll use for our power supply. We are planning on using a waterproof box to house all of our electronics in our laptop. That way we can make sure that none of that is damaged and that we are safe as well. There will also be lifeguards on duty so that we are safe too.
So this is our pressure transducer setup right over here. It is using a Wheatstone bridge hooked up to the data acquisition on LabVIEWs using basic voltage. It's going to be hooked up to our pressure transducer right here. And we have a beaker full of water, which would be a known volume. And once we weigh it on a scale and tare it and then fill it up with water, we would be able to calculate the density using mass over volume. So here is a full cycle of it running. You first turn it on. And right now it's doing that. It's reading all over the place, but the second I put it into the water, it immediately goes down, and then it's a little steady. And then I pull it out, and it goes back up. And this is all we would do.